Hello viewers, in today's class we are going to discuss one important definite integral in which the greatest integer function is involved, right? So here we have the problem, that is we have to find the value of this integral, and the value is equal to alpha e cube plus beta e square plus gamma e. Then we have to find the value of alpha square plus beta square plus gamma square, right? So what we will do here, we'll find the value of this integral in terms of e cube, e square and e raised to 1, and the coefficients, that is alpha, beta and gamma, will be determined, and then we can easily find out the value of this alpha square plus beta square plus gamma square, right? So let us start. So here let us call this integral as I, and we have 1 to e cube, and we have greatest integer function, that is log x to the base e, and here we have cube and dx, right? So here we see that the lower limit and the upper limits are 1 and e cube, right? So this is the lower limit and this is the upper limit. Now let us find out the value of this integral, right? So let us take u is equal to log x to the base e, right? So therefore when u is equal to log ex, then x is obviously equal to e raised to u, right? And therefore dx over du is equal to e raised to u, and dx can be written as e raised to u du, right? So here we have the value of dx in terms of u, right? Okay, now what we will do, we'll change the limits accordingly, because we are changing the variable from x to u, and when x is equal to 1, then the value of u is log e1, and the value of log 1 to the base e is 0, right? And when x is e cube, here we have x is equal to e cube, which is the upper limit, and u is equal to log e cube, because here we'll put x is equal to e cube, right? And this is e log e, and this is 3 times 1 is equal to 3. So here we have used the properties of logarithms, that is log m raised to n is n log m, and the value of log e to the base e is 1, right? So now once we have done all this stuff, we can rewrite our integral I as see here the limits changes from 1 to e cube, and here u changes from 0 to 3, right? So here we have 0, here we have 3, and for greatest integer log x to the base e can be written as greatest integer u, and here we have cube, and for dx we can write e raised to u du, right? Okay, so now we have to evaluate this integral, right? So here we see that the values of u varies from 0 to 3, right? And in between 0 and 3 we have two integers, that is 1 and 2, right? So now we can split this integral as a sum of three integrals, that is I1, I2 and I3, right? Now I1 is from 0 to 1, I2 is from 1 to 2, and I3 is from 2 to 3, right? So now here we can rewrite this integral as 0 to 1, then we have greatest integer u power 3 e raised to u du, then we have 1 to 2, from 1 to 2, and greatest integer u to the power 3 e raised to u du, and then we have 2 to 3, and here we have greatest integer u to the power 3 e raised to u du, right? So now we have three integrals to evaluate, right? And here we have the greatest integer function u, and we can write the value of greatest integer u in these three intervals, right? So the first one is when u lies between 0 and 1, that is 0 and 1, and the second one is when u lies between 1 and 2, and the third one is when u lies between 2 and 3, right? So when u lies between 0 and 1, then from the definition of greatest integer function, we know that the value of greatest integer u is simply 0, and here when u lies between 1 and 2, then the value of greatest integer u is simply 1, and here the value of greatest integer u when u lies between 2 and 3 is simply 2, right? So we can also verify the same by taking some particular values. Say if we take u is equal to say 0.5, right, and 0.5 lies between 0 and 1, so the value of greatest integer 0.5 is simply 0, right? And here if we take u is equal to 1.5 lies between 1 and 2, so therefore the value of greatest integer 1.5 is simply 1. This is 1, and here this is 0, and here if we take u is equal to say 2.3, because 2.3 lies between 2 and 3, so the value of greatest integer 2.3 is simply 2, right? Okay, so once we have decided the value of this greatest integer function u in these three intervals, here we can substitute 0, because the value of greatest integer u is 0. Here we can substitute 1, and here we can substitute 2, right? So now this integral is 0 because the value of this term is 0, so here we have 0, and here we have 1 to 2, and greatest integer u is 1, so this is 1 cube e raised to u du, and here we have 2, so this is 2 to 3, and we have 2 cube, and here we have e raised to u du, right? So now here this integral it becomes see 1 cube is 1, so we have 1 to 2 e raised to u du, and here we have 2 cube is 8, and we have 8, we have 2 to 3 e raised to u du, right? And we know that the integral of e raised to y dy is e raised to y, and here we have e raised to u and 1 to 2, then we have here 8, we can take 8 common, and the integral of e raised to u is e raised to u, and we have 2 to 3, right? And now we can substitute the limits here, So we have e square minus e raised to 1. We'll take the difference, and here we have 8 times e cube minus e square, right? So now this integral I can be written as e square minus e, and here we have 8 e cube minus 8 e square, right? So now we can rearrange the terms and we can simplify. So we have 8 e cube, then we have here we have 1 e square, and here we have minus 8 e square, so this is minus 7 e square, and here we have minus e, right? So the value of this integral is 8 e cube minus 7 e square minus e, where e is the exponential number. So now here the value of this integral is given by this expression, that is I is also given as alpha e cube, and here we have plus beta e square, and we have gamma e raised to 1. So here also we can take 1. Now if we compare these two expressions, we see that alpha is equal to 8, because here the coefficient of e cube is alpha, here the coefficient of e cube is 8, and here the coefficient of e square is beta, and here the coefficient of e square is minus 7, and here the coefficient of e raised to 1 is gamma, and here we have the coefficient of e raised to 1 is minus 1, right? So now we have to find the value of alpha square plus beta square plus gamma square, and we have obtained the values of alpha, beta and gamma. So this is 8 square, then we have minus 7 square, then we have minus 1 square, so this is 64, this is 49, and this is minus 1 square is 1, so this is 64 plus 50, and this is 1, 1 and 4, right? So the value of alpha square plus beta square plus gamma square is equal to 114, right? So viewers, this is how we solve this problem, and here the value of this integral is given by 8 e cube minus 7 e square minus e, and we have to find alpha square plus beta square plus gamma square, and the value of this expression or the integral is given by this expression. So we'll compare both these one, we'll get alpha, beta and gamma, and then we can square alpha, beta and gamma, and then we can add up the three terms to get 114, right? So this is how we solve this interesting problem.